midterm project video for the fall semester of 2019 for 15112. My name is Devank and my project's name is Encode-Decode. It's a simple cryptography tool that allows users to learn more about encryption mechanisms and decryption mechanisms and how to encode and decode to and from these respectively. It also allows you to learn more about the history of these encryption mechanisms and how they came to be in the first place. It's all organized into one file, which is about 1600 lines of code to make it simpler for the user to use. All you have to do is when you get to the main file, just run it once. It will create a modal window, which is over here. So I'll walk you through the different splash screens in every single encoding mechanism, and I'll decode some examples for you, and that should be that. So as you can see, it says press something to continue. So you press something to continue. The left side says encode, and the right side is decode. So let's walk through encoding and visualization first, and then I can decode some examples for you. So Morse code is the very basic one, which is the international recognized Morse code. You simply put in your text, press enter, and that's your Morse code version of that. Yeah, and the visualization for this is pretty straightforward, because Morse code itself is just essentially a bunch of dots and dashes corresponding to certain values. So I'll just show as to how each value corresponds to which dot and dash, and therefore you can have your own Morse code encryption mechanism. Let's go back to Caesar cipher. This is where things get interesting. So it asks you to enter a key and a text. So let's put in 3 as a key, and let's put in Devank as a text. That's my name. When you press enter, that's my name encoded with a shift of 3. When you visualize it and you do this again, it'll show you how each letter of the Devank shifts to that with the shift. So that this encoding mechanism over here shows you how D plus 3 gets you G, E plus 3 gets you H, and so forth, and how all of these combined then gets you your your encrypted message. Right, going back to a fine cipher, this is a value that takes two constraints, A and B, and the only restraint is A and 26 cannot be co-prime. So as we know, 3 and 26 aren't co-prime, so we put in 3. We put in 112 is awesome as a text, hypothetically, and we put in the value of B as 7. Why not? That is our affine encoded version of 112 is awesome with these constraints. Same thing to visualize it. We put 3 and we put 7 as the B value, and let's just make it 112 for simplicity's sake. So as you can see, it'll show you how each of 112's letters are changed to the corresponding encrypted version, and how these combined get you the encrypted version. So yeah, Bacon cipher is very similar to Morse code, where it has a bunch of A's and B's corresponding to their respective letters. The way it works is it assigns every letter a bit value and then gives every bit value either A or a B. So that's the table that you use. International Baconian cipher is the name, right? And the last one is a railfence, which converts every string into a 2D matrix with the length being your key. For example, let's make it why not hypothet. Actually, let's make it awesome. Sure. That is awesome encoded with a railfence encoded 3. The visualization for this works also in a very similar manner. You put in 3, you put in awesome, help, why not, and then it shows you how the 2D matrix it creates and how it reads this. So as you can see, it says read left to right, top to down. So left to right is AOHWSM space EPEEL, which is what you get over here. So these are the and then you can learn about each of these by clicking on the corresponding learn more box. For example, for our railfence, you can just click on this. It will guide you to the Wikipedia link for the railfence cipher. Yeah, and it does so for the affine cipher and every single encryption mechanism used. There we go. Now for the decoding bit, works in a very similar manner. Or you go to the decoding aspect, learn more goes to the same pages. For Morse code, you can put in let's try SOS, because that's the one I remember off the top of my head, which is this. As you can see, it goes to SOS. Yeah, so you put in any dots and dashes. If you didn't put in a letter, it just won't take in the value. It only takes in dots and dashes as the values. So yeah, that's Morse decode. Caesar cipher works in a similar way. 5 Devank, for example, would give you this. We could try. I can show the validity by putting this in Caesar encode with a shift of 5, and you'll get Devank. You know what? I might as well. It's YZQVIF, YZQVIF, YZQVIF 5 YZQVIF Devank. As you can see, the work, yeah. Same thing for affine decoding, Bacon cipher, and railfans, as you've seen. But yeah, that's basically the project. It's a cryptography tool that helps people get into cryptography. And thank you so much for your time.